Okay. Good morning, students.
मैम आवाज फार बारीक है.
आवाज बारीक येतो. तर काही सेटिंग चेंज नाहीये. हॅलो, येतोय?
Yes ma'am.
So we will start with the last, I'll say, experiment, because next is I don't know how I can show that one. Okay. If I'll just try, if it is possible to show you the next experiment, I'll show. Otherwise, we will discuss in the next lecture itself. Okay. So this experiment is just the distance measurement or the obstacle detection using ultrasonic sensor. So we have already discussed what is ultrasonic sensor, how it works. Okay, so it is the sensor which works, which is continuously emitting the ultrasonic waves, and if any obstacle comes in between, so it will simply reflect those waves, and it will be collected by your sensor, and based on that how much time it took to travel or to collect that wave back, duration through the code, and using the time duration we can calculate the distance covered, because we know what is the speed of this ultrasonic sensor. Okay, so based on that speed and time duration, it is taken to just receive it back the same signal, so the distance can be calculated. Okay, the sensor that we are using is HC SR04. So it is having this distance range, or the obstacle within this range 2 centimeter to 400 centimeter can be detected by this particular sensor. Okay, so actually last time or actually it has been planned to take this experiment using Raspberry Pi, but it's not possible. So I have just modified this write-up for Arduino itself. Okay, and we are going to see using Arduino. Only the intention behind using this Raspberry Pi is so how to use your Raspberry Pi. That was the intention, and most of you might have, many of you might have used this Raspberry Pi. So basically how to install your OS on Raspberry Pi, how Raspberry Pi works as the small computer, portable computer. So just to explain that one, so Raspberry Pi has been introduced in the last experiment, but here um, it's not possible, so I'm going with the Arduino itself. Okay, so basically two things that require, one is the controller and second is sensor. It's very simple connections. So this particular sensor is having 4 pins. Okay, out of which 2 are required for VCC ground, and 2 is like trigger and echo. Okay, so trigger is unless this sensor receives the trigger signal, uh, it will not transmit that particular ultrasonic sensor signals. Okay, so only when you apply the trigger signal to this particular trigger pin of the sensor, it starts emitting that ultrasonic waves, and those will be just emitted in the form of 8 pulses. Okay, which is known as chunk of pulses will be emitted, and it is waiting for receiving those pulses back. Okay, so which is received by the same echo pin. Okay, so and based on how much time it will take to transmit and receive. Okay, so just to transmit this wave and receive it back at the same pin, based on that we are performing few calculations in the program, and through that we are calculating the distance of an obstacle. Okay, so we are going to implement, I'm going to show you how to implement that on Proteus also. as well as we will see how it works in real time. Okay, so first I'll explain you Arduino code. It's very simple actually. No header file is required here. It's a simple sensor which where we are using the trigger and echo pin of that particular sensor. Trigger is acting as input, where we are providing a pulse, trigger input, high pulse, representing that it to activate, in short we can say, to activate your sensor. Okay, and echo is nothing but it will transmit and receive the signal, ultrasonic signal. Okay, so only these two pins are sufficient. As here you can see, trigger pin is connected to pin number 7 and echo is connected to pin number 6. So you can directly use these pins in your program, or I'm just for understanding here it has been initialized. Trigger pin is assigned the value as 7 and echo pin as 6. Okay, so whatever numbers or pin value, pin number you are using in your program, according to these numbers you have to make the connections. I'll show you connections also. So connections are nothing but simply we have to connect VCC. We have to get VCC from the Arduino, ground from the Arduino, and as I said, this trigger pin is connected to pin number 7 of your Raspberry Pi. I think the diagram is there, and echo is connected to pin number 6 of the sorry, not Raspberry Pi, Arduino. So I'll explain this also. Okay, a Raspberry Pi circuit. So why there is need of this voltage divider circuit? Anybody knows? We are not directly connecting our echo pin, or this is, I think, yes, echo pin is not directly connected to the Raspberry Pi. Okay. Do you know the reason behind this?
No, ma'am.
No. Okay. So this actually Raspberry Pi works on 3.3 voltage, whereas the signal which has been emitted by the ultrasonic sensor is 5. To the particular pin, whatever pin similar to that 7 and 6, you need to decide which pins you are using for echo and trigger, and accordingly you need to make these connections. Rest everything are same. We are using VCC, we are using ground. Okay, so accordingly you can just make the connection. So this is representing ground. Ground is connected over here. This second ground is connected to the ground of ultrasonic, and the second end of your this voltage divider circuit is connected to ground. Okay, so only that is the reason. Rest everything remains same, and then we are using Python programming for Raspberry Pi, whereas here the normal your Arduino programming. Okay, so just wow, so circuit diagram is very simple. Okay, the connections, only 4 connections you have to make for this ultrasonic sensor. So once we have decided these pins, few variables are declared. Just what is the duration, time taken to receive the signal back, the distance traveled we have to calculate. Okay, and then we are initializing these pins as input and output. Okay, so trigger pin is initialized as an output, and echo is as input because it has to receive the transmitted signal. Okay, so as soon as trigger pin get trigger pulse, it will start emitting that ultrasonic waves, and that will be received by echo pin. So your trigger pin is set as output, and echo pin is set as input. Okay, so and serial monitor to just get the distance, to see the distance we're using serial monitor. Okay, so either instead of serial monitor, or instead if you are using it in real time and you wanted to see the distance, okay, so we can interface LCD also. Okay, so on LCD, instead of serial monitor, we can observe the values on the distance on LCD also. So that part you can include in your program. Okay, so here we are interested in just finding the distance whenever an obstacle comes, whether it gives us the accurate distance or not. Okay, so this is all about your setup. And in loop, simply what we are doing is, initially we are clearing the trigger pin by just sending the low pulse. Okay, after 2 microseconds, again we are sending this high, so that means trigger is to your trigger pin. Okay, trigger has been applied only once, and then again that pulse is made low, and this procedure is continuously repeating as we have written this in loop. Okay, so that means just we are applying low pulse, that is low signal, then high for 10 microseconds, and again it will be low. And once that high pulse will be received by trigger pin, it will start transmitting the signals, and we are reading that particular echo at the echo pin. Okay, so pulse in is the function which will give us the time taken to receive that reflected signal from the object. Okay, so pulse in bracket echo pin, and high is whenever it is receiving high signal. Okay, so whenever it is receiving high signal, the instant the duration at that time, or the time where the trigger signal has received the high signal, trigger pin has received the high signal, and echo pin has received the high signal. So that duration will be calculated, and it will be assigned to this duration variable with the help of pulse in function. Okay, so once we have received this one, or once the duration has been opted, so distance can be calculated simply speed into time. Okay, so the speed, how much is the speed for this ultrasonic sensor? So it is given as the speed of sound. Okay, is 343 meter per second, or 343 3000 34,300 centimeters per second. So this is the standard. Okay, so either you can divide the speed by 2, because why we are dividing that by 2, because time is time is nothing but time taken to transmit and receive that signal back. That is, the distance traveled by your signal is twice the actual distance, and that is why we are dividing that this whole combination, speed into time, by 2. Okay, so simply based on that, we are using this 0.034 by 2. So simply converted that into this distance that we are getting will be in terms of centimeters. Okay, and this is what the same distance we are trying to display on the serial monitor. Okay, so again I'll show you the connections, and just we'll upload that, and we will see whether we will get the actual distance or not. Okay, so any difficulty in code is very simple. Actually, there is nothing complex in the code. See, this is the ultrasonic sensor that we are using. Okay, so you can see there are 4 pins. So this is representing ground. The red is connected to eco, blue is connected to trigger, and this yellow wire is connected to VCC. Okay, so these connections are made on your Arduino like this. This is representing your eco and trigger 6 and 7, and here we are taking VCC and ground. Okay, so only 4 wires you have to connect to this sensor. The Arduino is connected to the serial, this USB port, and now we will upload, and I'll show you the distance that has been measured by this sensor. Hi. Ako yung man. It's compiling and it will upload onto the Arduino. What happened? Okay, we have, I think, not selected the port. Yes. So you need port every time you are uploading your code. Done uploading, so we will see the distance now on this. No. So you can see the distance. Now I'll just open the camera. I'll just hold this and you can observe the distance. You can, I think, predict the distance. See here. I have just holded my hand in front of this sensor and you can see it's giving me 6, 7. That is, my hands are not stable. Okay. So if I just bring my hand in front closer to that sensor, now I hold my camera, this mobile. See here, you can just see the approximate distances, or it is giving us 3 centimeter. If I just take it far from this, the distance is increasing. You can predict, I think it is approximately, it is showing 7, 8, 10. Now I'll just hold it like this and you can observe. So this distance is approximately, I think, 50, I assume that, and we are getting the same thing. I'll just hold my sensor towards the roof. Okay, and you can see there is the white ply, and your signals are getting just reflected from that white ply. Okay, so this is the ply. You can just see. Okay, so it's getting reflected from that ply, and we are getting distance as 53. So I could not see exact 400 centimeters, but approximately till 200 it will give us the readings. Okay. Now again I have changed the orientation, and it is giving me distance between this box and the sensor. Okay. So this is how it will work very accurately, and it's very easy to just connect that particular sensor and make it work. Okay. So any doubt in this?
No, ma'am.
No. Now how to implement this on Proteus? Okay. So I'll show you the Proteus working. Now, how many of you remember the steps to work with the Proteus? What things we require to make your circuit working in the Proteus?
Hex code of the Arduino code.
So hex and that IDX, the library files, not hex code, the library files, that is .idx, and I'll just check one more file. Those two files you need to copy into the library, Arduino lab, this Proteus hardware library. Okay, so for that, just I'll show you those files first. It's ultrasonic sensor. So 3 files we have. Few components are having only the files related to your library, that is .lib and .idx. So these 2 files you need to copy into the Proteus hardware library, component library, and that you can find on C drive. This program data, usually this folder is hidden. You need to unhide that folder. So under this program data, you can find Lab Center, Electronics, and in this Proteus 8 Professions, under that library, and here you need to copy that these 2 files, not hex files, library files and .idx file. Okay. So similarly, there should be the library files related to your Arduino that we have already pasted in this folder. Okay, so here you can find this Arduino IDX and Arduino lib. Okay, so these files should be there, then only your component works in the Arduino. Okay, so once we have copied those, the second thing is you just double click on this ultrasonic sensor, and the hex code related to that you need to copy. The hex code, that 3 files I have shown you in the Proteus library. Okay, ultrasonic, that files required for Proteus library. Okay, from that you need to set path for this hex file here. Okay, you have to set, which is already set. You can set that particular path here by selecting that file, and you have to simply click on open. Okay, so this hex file should be set for this particular ultrasonic sensor, and similarly for Arduino we need to mention the path of the hex file of the code related to your ultrasonic sensor. That means you need to again compile this file. While compiling, you have to select this option should be ticked, compilation option should be ticked. After just selecting that option, you have to compile your file. Okay, I think every time you'll run your program, you need to update this particular hex file into the Arduino, because it's changing, or I think those are the temporary files that will be created by this particular program. Okay, so you need to set that path every time you are executing the Proteus that design. So you can find here the hex file corresponding to our code, and that code you need to simply upload, or you need to define the path for that this hex file of this code into the Arduino. So then compiling, where we can find, yes, here is the path. You have to simply copy that path from here, paste it into the address bar, and simply remove those double lines slash, and copy this path and simply paste it into the that Arduino into that Arduino component. Okay, so I have just copied this one. And you have to replace the existing. If it is not there, you can directly place it, paste it. Okay, I have pasted this. You can set the path if you know that complete path. You can set it from here also. Okay, so you can select that C drive and whatever are the folders. Okay, from here, and you can set the path directly from here. Okay, so I have just copy pasted that path and just click on OK. And once you have done with all these steps, you are ready to run your design. Okay, so I just executed this one. See here, you can see this distance which is giving. Actually, what we have used here is the potentiometer, and based on the variable voltage or the variable resistance, the distance will be represented over here. Okay, so here we cannot actually move or show any obstacle, so that obstacle is represented with the help of variable resistance, which is connected to this trigger pin. Okay, and here simply your trigger and echo, so same connections have been made. As it is virtual component, no need of any supply voltage. Okay, VCC and ground, and you can observe this distance. Now I can change this distance by, here you can find plus and minus for this potentiometer. If you click on this, the distance will increase. And you can see this position of the this arrow position is also changing. Okay, so the maximum, we'll see till what it will show us the maximum value. The maximum is, I think, 1100 something it will give us. So this is the maximum point we have reached. Yes, 1104 is the maximum, and same way I can reduce, which is representing. It's reducing. Okay, so this just the simulation. Same way, if we just change the obstacle, the distance, it will change the distance. So minimum distance captured or represented here is 4. Okay. So this is how you can simulate this particular practical onto Proteus. Okay. So you are supposed to implement this diagram, circuit diagram, and you have to upload the copy of this screenshot of the circuit and the readings on this virtual terminal. Okay, virtual terminal is connected in between this transmitter and receiver. Okay, is that clear? So actually I wanted to show you full, that is how it will scan the full range or in the range of 0 to 180 degree. So that is possible, and how we can sense that area using processing ID, processing software. Okay, so that you can search and go through that, or I'll just share you the link corresponding to that, because it requires actually the servo motor. Your sensor is mounted on the servo motor, and you have to decide the area, that is in how many the area through which your servo motor will rotate. Okay, the angle through which your servo motor will rotate, that is from 180 to 180 or from 0 to 90, how much area you want to capture, and based on that your servo motor is continuously rotating. Accordingly your ultrasonic sensor is also rotating, and it is capturing the larger area. Okay, so depending on the application where you are using, so this can be another arrangement. You can use your ultrasonic sensor along with the servo motor. So your sensor, I am not able to just mount this your ultrasonic onto the servo motor. Okay, you need to fix that onto the servo motor, and you have to simply operate that servo motor, and based on the trigger input your ultrasonic sensor will give you the output. Okay? So this is how you can use it for various applications for covering larger area rather than whatever is the limited one. Okay, and this is having very short range, that is 200 meters. So based on your application you need to find the suitable sensor which will cover the required area, and accordingly the working principle or the coding, this logic will remain same. Okay, so I think it's clear. Any doubt?
No, ma'am.
And with this we have finished our 7 experiments. You have to write the post lab questions. You have to implement this in Proteus and just upload everything onto this Teams. Okay, so I think if you are not having any doubts, we should stop here. Okay. I have already shared this code with you, the Arduino code. You can use that code for your Proteus also. The same code has been used for Proteus. Okay, and check the working of that. So for this, actually, you need to search for potentiometer. You can search here Arduino. I'll again repeat that. If you are just writing here Arduino, you cannot find that Arduino directly, or that name, actually we are not using this Arduino. Okay, so these are representing your SIM or GPS. So you can find that Arduino under emulators, and we are using this first one, 128, Mega 128. Okay, sorry, we are using Arduino Uno, not Mega. Okay, so under emulators you will find that one. For potentiometer, you can write the potentiometer, but you can find that potentiometer under resistors. Okay, So when you click it on this resistors, you can find that pot. Okay, so use this pot and set the value. Here it is used as, okay, need to stop this simulation. Okay, so the value is mentioned. You can just click on that component and you can change the value. Okay, so 1K pot has been used here, and you can find these 2 points to change the range. Okay, and accordingly you get that value on this virtual terminal. Okay, so this is what you need to implement, and rest all the things virtual terminal you'll find here somewhere, or you can just search for the virtual terminal also. Okay, so with this I think we will stop for today. Okay, so the last experiment we will discuss on Monday, because Monday anyhow we will finish our syllabus in first half an hour. So I'll show you the dongle that we are using, or the port, the component which is connected to the port, and how we can get the values from that particular port. Okay, so we will stop for today then. Okay, so I'll end the meeting.